First, the components we have on this generator. Number one is the voltage regulator. Number two, excitation field. Number three is the excitation armature. The number four is the diode bridge. Number five is the main rotor, which is inside number six, main stator. Number seven is the permanent magnet rotor or PMG rotor. Number eight is the PMG stator. The question is, how does this work? So if we have a genset, let's say with an output of 400 volt and 50 hertz, voltage regulator will sense this output. The function of the voltage regulator is to keep this output voltage at that level. How will do it? He will play with the excitation field, applying less or more voltage as per the input sensing to produce a magnetic field here. This magnetic field will increase if the voltage regulator apply more voltage, and in consequence more current is coming through the coils. Because the engine is rotating, because the engine is turning, and the main rotor and these components are also tied to the main rotor, movement, magnetic field, and coils will produce a smaller three-phase AC voltage on the excitation armature. This excitation armature voltage is going to the diode bridge or the diode rectificator. This will convert the AC voltage to DC voltage going to the main rotor. The DC voltage from the diode bridge is coming then to the main rotor, which will produce a bigger magnetic field. Still in movement, this bigger magnetic field will touch the coils on the main stator. Because there is magnetic field, coils, and movement, then will produce the output voltage, which is 400. The RPMs and the speed will give you the frequency. That's why we cannot change the speed of the engine, and will be always fixed to get the proper frequency. Let's review then the signals we have on this closed loop on the alternator. We have from the main stator, we have AC signal going to the voltage regulator. From the voltage regulator to the excitation field, we'll have DC signals or DC power, DC voltage. After the excitation system to the diode bridge, we'll have AC voltage. From the diodes to the main rotor, we'll have DC. And then the cycle is closed. Cycle repeats. What is then the function of the permanent magnet? Permanent magnet will have a magnetic field always on the rotor. That's why it's called permanent magnet. This magnetic field, because it's tied also to the rotor shaft, this magnetic field will move movement plus magnetic field plus coils on the permanent magnet stator will produce a three-phase voltage. This is around 100 volts, might be less, might be more. And in 50 Hz systems, typically will have 200 Hz output. This three-phase voltage, which is AC, is going to provide power to the voltage regulator. So the voltage regulator will sense from these lines a will power from these lines to the generator, to the alternator. The output voltage will decrease. So the voltage regulator will sense this decrement on the output voltage, and to increase it, need to apply more DC voltage to the excitation field, producing more DC current to this excitation field, increasing the magnetic field over here, increasing the AC voltage over here, and by consequence increasing the DC voltage to the main rotor, which at the same time will have more magnetic field and will recover the output voltage to the desired level. This will happen anytime load is increased by the final user or the customer. More load, voltage will decrease, output voltage will decrease for a couple of seconds. Voltage regulator will sense that the output voltage is lower, will increase the excitation voltage, will have more excitation current, more magnetic field, more voltages, and then the voltage, the output voltage will recover to the desired value. Now, when the load is reduced, this output voltage will tend to increase. Then the voltage regulator will do the opposite, will decrease the excitation voltage, will decrease the excitation current, and will reduce magnetic field just to the level to get the 400 output voltage again. Thanks for watching. I hope this has been useful for you.